This is Group 9's project submission, the stress monitoring system. So it starts off by initializing the system, then place your finger string on the OLED screen will let the user know it is ready to collect data. Then you can proceed to place both your index fingers on the MX30102 chip in the top left and the Dallas temperature sensor on the bottom right. The three dots on the OLED screen lets the user know that it is collecting data. We are using our fingertips because we are collecting surface body temperature and not core body temperature. This is because in high stress situations, blood does not flow to the fingertips, and the average temperature of the fingertip is 93 degrees Fahrenheit, so we're looking for something in that ballpark. For the full metrics, we record the data using 20 samples each, except in the Arduino code, except for HRV, which we use 30 samples. This is because HRV is the statistical deviation of IR intervals, which is the time between beats. So once the data has been collected, done will appear on the OLED screen as seen there. So the reason why it's taking longer for heart rate and HRV, it's because we added buffers and filters to the Arduino code to cancel out any faulty data. So once everything's been collected, it will be transferred to the app, which was coded using Python and run using Streamlit. So Streamlit converts the Python code to a web monitoring app. So as you can see here, we press get live data and our data will show up, and it will also calculate a stress score. As you can see here, I have a stress score out of 50 out of 100. So higher stress means a higher stress score. Lower stress will mean a lower stress score. So this is essentially an average of all of our metrics. And to calculate this, we calculate these specific values for each of the metrics. We reference them using a literature study. So for heart rate, HRV, and temperature, those values are cited in the slide titled stress score. Thank you. Okay, so this is our prototype device created by Tyler. So it is a 3D printed device, which is held on the wrist by two straps. So on our left index finger is the MX30102 chip, and in the internal housing of the 3D printed device is the ESP32 chip soldered to the PCB board with all the necessary wires. We also have 3 AA batteries serving as an external power source. And to the bottom of the device is our temperature sensor, which is meant to sit on the wrist and collect body temperature. So the reason why we didn't use this in our prototype video is because we made a few upgrades. We added the GSR sensor and an OLED screen, but this is how our final product or prototype would have looked.